Yes. Hello students. Welcome to the session. Yes sir. Welcome to Unacademy GATE English. Sir, before starting the today concept, sir, let me introduce myself. Students, my name is Surendra Babu. Yes sir, for 10 years I am educating the students for GATE, ESE and PSUs in electrical and electronics engineering. These are the subjects I am teaching for electrical students. That is power electronics, power systems, electrical missions, electrical and electronic measurements. Yes sir. These are the subjects I am teaching for electrical students, sir. That is power electronics, power systems, electrical missions, and electrical and electronic measurement students. Sir, this subject I am teaching for instrumentation students. That is the transducers and mechanical instrumentation, sir. Sir, is it audible? Sir, is it audible? Yes, all of you, good evening, sir. Students, apply my promo code BABU10. Get the 10% discount on Unacademy Plus subscription, sir. And you also use my promo code BABU10 to unlock our Unacademy learning app, sir. Yes, students, please concentrate, sir. These are our Unacademy subscriptions. There is a plus subscription and iconic subscription, sir. If you select the plus subscription, these are the benefits we can get, students. Sir, live classes, crash courses, weekly tests, doubt solving sessions. That is in English and Hindi, sir. These are the benefits we can get if you select the plus subscription, sir. Students, see the one more subscription, that is iconic subscription, sir. If you select the iconic subscription along with plus subscription, this extra benefits is also added to this extra benefits is also added, sir. You please concentrate, sir. Personal coach is available, study planner, study booster sessions, personalized test analysis, preparatory study materials, sir. Yeah, this is personal care is taken in iconic subscription, sir. That these are the benefits. Extra benefits are provided, sir. This is plus batches and this is iconic. If you select the iconic subscription along with plus subscription, these extra benefits are added, students. Sir, you please concentrate, sir. You please concentrate. Yes, all of you, good evening, sir. All of you, good evening, sir. Students, now it is okay. Sorry, sir, small technical problem. Now it is okay. Is it audible, sir? Students, now it is okay. Yes, sir. Okay, this about plus batches taken by our top educators, sir. Sir, this is our Unacademy combat, sir. The next combat goes live on January 12th, sir, 2021 at 6 p.m. sir. It's for register now for free, sir. After two Unacademy combats, after successful completion of two Unacademy combats, then this is the third program, sir. The next combat goes live on January 12th, sir, 2021. Please students, you please register now, sir. It is for free, sir. This will be start on January 12th, students. Earn rewards for your hard work, sir. Participate in Unacademy combat and earn the rewards, sir. You please concentrate, students. Yes, sir. Sir, this Unacademy GATE English January month schedule, sir. Along with the timings it is given, students. You please follow these timings, sir. Measurements, electrical missions, aptitude, communication, engineering, mathematics, analog electronics and maths. All these subjects are going on. Please concentrate, sir. Along with the timings it is given, sir. Our measurement subject for GENCO, TRANSCO, DISCOM and AW and AE foundation is every day 7:30 p.m. to 8:30 p.m. students. The 7:30 p.m. to 8:30 p.m. from Monday to Friday, sir. The timing is from Monday to Friday, sir. Measurement for GENCO, TRANSCO, DISCOM, AW and AE foundation is from Monday to Friday, sir. You please concentrate, sir. Along with the timings it is given, students. Please follow the timings. Sir, this is announcement, sir. Who are asking for power system continuation? We are not stopping the power system subject, sir. We are continuing. This power system for GATE, ESE and PSU, sir. Who are preparing for GATE, ESE and even for GENCO and TRANSCO, GATE point of view, ESE point of view, in all the aspects point of view, the syllabus will be covered, sir. This YouTube live classes only Saturday and Sunday, sir, at the rate 7:30 p.m., sir. The measurements subject is Monday to Friday, sir. But our power system subject Saturday and Sunday, sir, at the rate 7:30 p.m., sir. The topic is power system stability, sir. The next topic, already 3 concepts are completed, sir, in power system. That is current system analysis is completed. Symmetrical component is completed. Fault analysis also completed, students. Fault analysis also completed. The next topic is power system stability, sir, at the rate 7:30 p.m., sir. Every Saturday and Sunday. Every Saturday and Sunday, students. Sir, you please concentrate, sir. And every day at the rate 9:30 p.m., sir. 9:30 p.m. Special classes live on Unacademy learning app, sir. Special classes live on Unacademy learning app, sir. Every day at the rate 9:30 p.m. students. Please utilize this one who are preparing for GATE 2021 also, sir. The important topics will be covered, sir. That's why I selected. In Saturday and Sunday I selected power system stability, sir. In special classes live I selected load flow studies, sir. Already 3 main important concepts are completed. Next 2 more main important concepts for GATE point of view. Power system stability and load flow studies, sir. Load flow studies. This power system stability will be covered in Saturday and Sunday, students. The load flow studies will be covered every day up to syllabus will completed every day at 9:30 p.m., sir. This is the special class live on only an Unacademy learning app. Students, please download our Unacademy learning app. Please follow all these lectures, sir. And inform to your friends also, sir. Who are asking power system subject, please follow this one. Even GENCO, TRANSCO students also you follow, sir. The new concept, stability I am starting every Saturday and Sunday. The Saturday and Sunday, that stability will be continued. Then load flow studies will be started at 9:30 p.m., sir, every day. Tomorrow onwards, this schedule will be continued, sir. Tomorrow onwards. Every day 9:30 p.m. Our special classes live on Unacademy, sir. As students, please concentrate, sir. 2 topics parallelly I want to complete. That's why it's selected stability and load flow studies, sir. Please concentrate. Who are preparing for 2021 also, it is more useful, sir. It is more useful. Very important topics I am discussing, sir. Yes, students, please concentrate, sir. And inform to your friends also, sir. Yes, students, we'll see the today concept, sir. The topic on electrical and electronic measurements. Today I am going to discuss what are the different types of electrical and electronic measuring instruments, sir. What are the different types of electrical and electronic measuring instruments, sir? Yes, students, please concentrate, sir. You please concentrate. Yes, sir. See, in the last session, I given some introduction to this generalized measurement system, sir. You complete this one, then we'll continue with what are the different types of electrical instruments, sir. Sir, I told already, any generalized measurement system consists of the primary sensing element. Actually, it consists of transducers, sir. The starting block is transducers, sir. The starting block is transducer, students. It consists of transducers. A transducer is internally consists of sensor plus transduction elements. Sensor plus transduction element. Yes, students. Please concentrate, sir. Sensor plus transduction elements. Sir, what the sensor can do, sir? Which senses the physical parameters, sir? Which senses physical parameters, sir? Which senses the physical parameter? Which senses the physical parameters? Here, physical parameter means which senses the physical parameters, sir? What the physical parameter here, sir? The quantity to be measured is nothing but a measurand, sir. The quantity to be measured is nothing but a measurand. What do you mean by measurand? The quantity to be measured, sir. What are the physical parameters, sir? Here we can apply some physical parameter: force, pressure, yes sir, pressure, flow. You can apply some level. All these are the some physical parameters, students. All these are the, even temperature also you can apply. Temperature also you can apply. All these physical. This physical parameter is sensed by which one, sir? Sensor. Internally, actually it is a transducer, sir. This block is actually transducer block. The transducer block internally consists of, the first stage is sensor, sir. The first stage of the transducer block is sensor. The second stage is transduction element, sir. Then which senses the physical parameter, which converts physical parameter into change in displacement, sir. Which converts a physical parameter into change in displacement. Which converts a physical parameter into change in displacement, sir. Change in displacement. That means which converts the a physical parameter into change in displacements. That means a physical parameter is converted into a mechanical quantity. Actually, a sensor senses the physical parameter that is converted into change in displacement, or which converts into mechanical form, sir. Which converts into mechanical form. Now, what the transduction element can do, sir? What the transduction elements can do? The change in displacement is converted into electrical, sir. The change in displacement is converted into electrical, or it is a transduction element is nothing but it just like act as the electrical transducer, sir. Electrical transducer. Sir, point to remember, students. In general, transducer means, sir, in general, it is not mentioned that is a electrical transducer or mechanical transducer. In general, transducer means which converts one form of energy to another form of energy. Which converts one form of energy to another form of energy, sir. Another form of energy. That is called transducers. Generally, transducer is definition this one. Now, what I am telling that this transducer consists of two elements: sensor and transduction element. Transduction elements. Yes, students. Transduction element. Then what the sensor can do, sir? Which senses the physical parameter and converts into, which senses the physical parameter and converts into change in displacement. That means just like a mechanical quantity. Okay, that's why this sensor acts as a mechanical transducer. It is also called mechanical transducer. A sensor acts as a sensor is nothing but a mechanical transducer, which converts a physical parameter into change in displacement or mechanical quantity. That is nothing but a mechanical transducer. Sir, what the transduction element can do, students? Transduction element can do this mechanical quantity is converted into electrical quantity, sir. The mechanical quantity is converted into electrical quantity. That's why a transduction element acts as a electrical transducer, sir. It acts as a electrical transducer. A transduction element acts as a electrical transducer, students. Please concentrate, sir. A transduction element will convert the change in displacement into electrical. Who gives that change in displacement? Sensor, sir. Sensor, what it doing, sir? Which senses the physical parameter, converts into change in displacement. Understood? That means we are getting in the form of mechanical, sir. That output of the sensor is given to the transduction element. The transduction element will convert that mechanical quantity into electrical. That's why the transduction element is also called electrical transducer. Sir, students, what I am telling, sir, in general, transducer means which converts one form of energy to another form of energy. That point to remember, sir. Next, If specially it is asked, what the mechanical transducer, what the electrical transducer? A sensor is the mechanical transducer, sir. A transduction element is the electrical transducer, sir. What the sensor can do, sir? Which convert the physical quantity into change in displacement. That is convert into mechanical, sir. We are getting in the output is in the form of mechanicals. That's why it is a mechanical transducer. Output in the form of electrical we are getting, that is electrical transducer, sir. Which ones are? Transduction element. The transduction element acts as a electrical transducer which converts one mechanical into electrical, sir. Mechanical into electrical. That's why one more point to remember, students, here. A sensor acts as a primary transducer. A sensor acts as a primary transducer. Very important, sir. Which is the primary transducer? Generally, mechanical transducers are the primary transducers. That's why a sensor acts as a primary transducer. Which acts as a secondary transducer, sir? Yes, a transduction element. A transduction element is acts as a secondary transducer, which converts mechanical to electrical. Which converts mechanical to electrical. Then it acts as a secondary transducer. Yes, students, please concentrate, sir. Transduction element is also acts as a. This is the primary, sir. But this transduction element can act as a which transducer, sir? Secondary transducer. It acts as a secondary transducer. Yes, sir. You please concentrate. It acts as a secondary transducer. That's why, that means, sir, whatever the output from this block, what is the output we can get, sir? We can get the electrical output. From this block, which output we can get, sir? Electrical output we can get. From this block, we can get the electrical output. That means internally it consists of sensor plus transduction. Sir, one of the example for primary transducer is Bourdon tube, sir. Bourdon tube acts as a primary transducer, sir. Which is acts as a secondary transducer, sir? LVDT. Linear variable differential transformer. That is, it's not a transducer, sir. It is a transformer. Yes, GENCO, TRANSCO students. It is a repeated question in GENCO and TRANSCO, sir. Repeated question. Even SPDCL also. It is a repeated question, sir. LVDT stands for linear variable differential. It is not a transducer. It is a transformer. It is a transformer, sir. Because it consists of transformers, sir. You see this one, sir. This is the example. That's why this is our Bourdon tube, sir. This is our Bourdon tube. Which acts as which one, sir? Primary transducer, sir. It acts as a primary transducer. Please, students, please concentrate, sir. Which acts as a primary transducer, sir. Now, this is our LVDT, sir. This is our LVDT, sir. This LVDT acts as a which one, sir? Secondary transducer. Secondary transducer. Understood, students? Please concentrate, sir. Secondary transducer. Yes, sir. It is a secondary transducer. Yes, sir. Parallelly, I am teaching, sir. That's why you follow special classes, sir. Even that is also live, sir. You can have any doubts, then you can you can send the doubts also, sir. You can reply, no problem. Parallelly, I am covering, sir. That's because who are preparing for 2021, that is more useful. That's why, no doubt at all. This in detail I will give, sir. In detail I will give, for stability I will give, for load flows also. Parallelly I want to complete, sir. That's why you follow that. Yes, students. Now see, sir. This is the primary transducer. What the primary transducer can do, sir, I told already. For example, input is the pressure we are giving. This is the physical parameter. Whenever pressure is applied, this is one end of this Bourdon tube is fixed end, sir. Another end is movable, sir. This is the movable end. Whenever pressure is applied, then because of this pressure, this end is moving like this, sir. That's why there is a change in displacement. The change in length, sir. This displacement is changing. Now, this change in displacement is applied to which one, sir? Core. It's a movable core, sir. Now, this core is moving, sir. Now, up to this Bourdon tube, what it doing, sir? The physical parameter is converted into change in displacement. That's why it is a mechanical transducer. Now, the change in displacement we are giving to which one, sir? Our LVDT is giving to the LVDT, sir. Now, what this LVDT can do, sir? Because of this change in displacement, the core is moving, sir. When the core is moving, there is induced EMF in the, according to this movement of the core, there is induced EMF in the secondary, sir. There is induced EMF in the secondary, sir. That means, sir, the change in displacement is converted as electrical. That means we are getting induced EMF now. Induced EMF is which output, sir? Electrical output. That's why that mechanical displacement is converted into electrical. That is mechanical displacement. Yes, sir. The mechanical displacement is converted into electrical. Then it acts as which transducer, sir? Secondary transducer. This is the electrical transducer, sir. Understood, sir? This LVDT. That is the, you see this one. This total is nothing. It is a transduction element. It is a sensor. That's a sensor plus transduction element. Total is nothing but a transducer. Understood, sir? You please concentrate. Like this, we can get the electrical output, sir. Like this, we can get electrical output. Understood, students? What I am telling that? A sensor is a primary transducer which senses the physical parameter and converts into change in displacement. That is the mechanical displacement. Change in mechanical is we are getting mechanical displacement. That mechanical displacement is applied to secondary transducer. That is the transduction element. That is the secondary transducer. That transduction element, that mechanical displacement is converted into electrical form. It is one simple example to make the what is the primary transducer, what is the secondary transducer, what is the sensor, what is the transduction element. Yes. Then what is the mechanical transducer, what is the electrical. All these concepts can understand by using this simple examples. Sir, which is the primary transducer here, sir? Which is the secondary transducer here, sir? LVDT. Which is the mechanical transducer, sir? Which is the electrical transducer, sir? LVDT. Which is the primary transducer, sir? Which is the secondary transducer, sir? LVDT. Understood, student? You please concentrate, sir. That means finally the output of the transducer we are getting in the form of electrical. In the form of electrical we are getting, sir. Now, one more point to remember, sir. This transducer is also called pickup, sir. What is the another name for transducer? It is also called pickup. The transducer is also called pickup, students. Yes, sir, please concentrate. Now, the output of this transducer is given to variable conversion elements, sir. Up to this we are getting electrical output, sir. Up to this we are getting. Now, what is variable conversion element? Based on the requirement of data presentation element. For example, I want output in the form of digital. Then this variable conversion element, here I am getting the output is up to this analog. Now that what the variable conversion element can do, sir? That analog is converted into digital. Then if you want only digital out, only analog output, then this here I am getting only digital. Then the digital is converted into analog. That means this A to D and D to A converters are used as a variable conversion elements. We can convert analog to digital or digital to analog. That means here, sir, after that, this output of this analog to digital or digital to analog converter, we are giving to variable manipulation elements, sir. Which acts as a variable manipulation elements, sir? Amplifiers, attenuators is used as a variable manipulation element. But in this manipulation of amplitude can done without effect of actual shape, sir. Without affecting the actual shape of the measurand, we can make this manipulation, sir. We can amplify or we can attenuate the signal without affecting the actual shape, sir. Without affecting the actual shape. Then this is given to the data transmission element. This data transmission element will transfer to the data processing. This is a data presentation element or controlling element, sir. Which are acts as the data presentation elements, sir? If you want to measure that data, then we can use some indicating instruments. Use some indicating instruments, sir. Use some indicating instrument like normal voltmeters, ammeters, wattmeters. These are used as a data measuring instruments. You can also use recorders. If you want to record that data, we can use the recorders, sir. Then you also use CRO. If you want to display that data, we can use the CROs. Then we also use, if you want to monitor that data, use the computers also. Computers also used as the data presentation elements. Understood, sir? Recorders we can use, CRO we can use, some indicating instruments we can use. Even if the output is in the form of digital, we can use some digital meters. Understood, sir? All these we can use it as a data presentation elements. That means indicating instrument, recorder, CRO is the data presentation elements. Now see, study of electrical and electronic measurement is nothing but a study of this block, sir. That means we are studying electrical and electronic measurement means we are studying about this block, sir. This block is already studied your analog electronics or digital electronics. Already this block is completed, sir. But this, whatever this starting block is the transducer block, that block we are studying in the only instrumentation, sir. It is an instrumentation block. This is our electrical and electronic measurement blocks, sir. Data presentation or data measuring, data recording. All these study of electrical and electronic measuring instruments. That means once we are studying the electrical and electronic measurements means we are studying about data presentation element, data measuring elements or data recording elements. Okay, this is, our explanation is mainly this one, sir. At the end in the transducer, we go for this block, sir. But this block already studied in the other subjects, sir. Understood, students? You please concentrate, sir. Sir, what is the function of this variable conversion element, variable manipulation element, data transmission element, data presentation or controlling elements? Yes, sir. Please concentrate, sir. Yes, students. Sir, what is the variable conversion element? That I told already. After passing through the transducer, the output is in the form of electrical signal, maybe voltage, current, which may or may not be accepted to the system. Our system may not accept it, sir. For performing the desired operation, it may be necessary to convert this output to some other suitable form while retaining the information content of the original signal. This is important, sir. We can convert A2 to D or A to D or D to A without changing the information of the original signal. Because we want to get that signal at output side, sir. That's why if that information is changing, then we can't get exact signal. That's the reason why without changing, while retaining the information content of original signal. Example, if the output is analog form and the next step of the system accepts only in digital form, then we can use analog to digital converter will be employed. Okay, that is the meaning. What is the need of variable conversion elements? Sir, what is the variable manipulation elements? Sometimes it is necessary to change the signal level without change. This is important. Without changing the information. In the last session, I asked the question also, sir. This is one. Contained in it for the acceptance of instruments. Sir. The function of the variable manipulation unit is to manipulate the signal presented to it while preserving the original nature of the signal. Sir, what are the examples? I told already. Manipulation elements are an electronic amplifier converts a small low voltage input signal into high voltage output signal. Thus, the voltage amplifier acts as a variable manipulation unit. Yes, students, please concentrate, sir. Sir, what are the data transmission elements? These are required to transmit the data containing the information of the signal from one system to another system. For transmission of data, satellites is one of the data transmission elements, sir, which transfers the data from one system to another system. Sir, what are the data presentation elements? That I told also, sir. The information regarding measurement. What do you mean by measurement, sir? The quantity to be measured is nothing but a measurement, sir. Is to be conveyed to the personal handling. That means we are handling that instrument, sir. Then if you want to read that instrument, if you want to record that data, if you want to display that data, then we can use data presentation elements. Such a device may be in the form of analog or digital format. The simplest form of a display device is common panel meter with some kind of calibrated scale and pointer. Example is indicating type instrument. Indicating type is the one of the simplest form of the data presentation element. What are the voltmeters and ammeters? Those are the data presentation elements. Yes, students. In case the data is to be recorded, recorders like magnetic tapes or magnetic discs may be used. For control and analysis purpose, that I told, sir, computers may be used. We can use recorders, we may use the computers, we may use the indicating type instrument, we may use the CRO for display purpose, sir. All these are used as a data presentation element. In total, this measurement system block, what we are studying, sir, in our electrical and electronic measurements, we are studying about what is that one? Data presentation block. Data presentation element block we are studying, sir. Yes, students. Okay, this about what exactly a generalized measurement system. It is a generalized measurement system. What do you mean by measurement system? It's a combination of measurement plus instrument. It's the combination of measurement plus instrument. Yes, students. Now see what are the different types of instruments? Very important, sir. Please concentrate, sir. Very important, very important. Who are preparing for GENCO, TRANSCO and PSU's point of view, you please concentrate, sir. What are the different types of instruments? Students, that means I told already a measurement is a process. For every process, we can use the instruments. For every process, instrument we can use. Then what are the different types of instruments we are using? What are the different types of instruments we are using? In general, based on methodology, the instruments are broadly classified into two types. The instruments are broadly classified into two types. One is absolute instrument, another one is secondary instruments. Yes, sir. This absolute instruments is also called primary instruments. This absolute instruments is also called which instruments are? Primary instruments. Yes, students, please concentrate, sir. These are the primary instruments. In general, the instruments are broadly classified into two types. absolute instruments and secondary instrument. This absolute instruments is also called primary instruments. Is also called primary instruments. Yes, students, please concentrate. Yes, sir. What the absolute instruments measures? What is the definition of the absolute instruments? Yes, students, please concentrate. Which measures the unknown quantity in terms of physical constants of instruments. Which measures the unknown quantity in terms of physical constants of an instrument. Means, see, for example, we are measuring the voltage by using voltmeter. Then what the voltmeter will give, sir? Directly voltage it will give. We are measuring the current by using ammeter, means ammeter directly will give the current. But in absolute instrument, not like that, sir. In absolute instrument, not like that. Which measures the unknown quantity in terms of physical constants of instrument. Sir, in terms of physical constant means, in terms of, that means, by using absolute instrument, first we can conduct one experiment. From that experiment, we can get some physical parameters. Those physical values we can substitute in one form. Physical parameters means we can measure the area, we can measure the deflection, we can measure the flux density, we can measure the magnetic field intensity. Like that, so many physical parameters we can measure based on the type of instrument. Those physical parameters we can substitute in one formula that gives the reading. That type of measurement is nothing but a absolute instruments. Understood, students? Please concentrate, sir. Which measure the unknown quantity in terms of physical constants of an instrument. In terms of physical constants of an instrument. Which does not give reading directly. For example, I am measuring voltage. Directly I don't get voltage, sir. I am measuring current. Directly I don't get current. Then what you can do? I can measure some physical parameters. Then you can substitute in one formula. That formula will give the what is the unknown quantity we are measuring. That's why it measures in terms of physical constants of instrument. Yes, sir. These instruments are rarely used except in some laboratories and for other scientific works only. No calibration is needed in this type of instrument. No need of any calibration, sir. These instruments we can use directly, but these are not used in our daily life, sir. Why these are not used in our daily life? That I will explain, sir. But point to remember, these are used only in the standard laboratories and for other scientific works only. In research and development, in some scientific work only you can use. One more point to remember, sir. These instruments are also used to calibrate the secondary instrument. For calibration of secondary instrument, in the design of secondary instruments, these instruments are taken as a reference because these are the more accurate instruments, sir. Absolute instruments are the more accurate instruments, sir. Why absolute instruments are more accurate instrument? Because it consists of less number of mechanical moving parts. Once it consists of less number of mechanical moving parts, then power consumption is less. When the power consumption is less, whose accuracy is more, sir? Understood, sir? These instruments are used to calibrate the secondary instruments only. In the design of secondary instrument, like voltmeter, ammeters, wattmeters, in the design of these instruments, which instruments are taken as a reference, or absolute instruments are taken as a reference. Understood, students? Point to remember, sir. Which measures unknown quantity in terms of physical. These points you remember, sir. Okay, this absolute instruments. Here I given. These are having less number of mechanical moving parts, sir. Less number of mechanical moving parts. Hence, less power consumption and more accurate instrument. These are the more accurate instruments. Because these instruments are not used in our daily life, sir. Because of time consuming process. Yes, sir. Very important. Why these are not used in our daily life? Measurement using absolute instrument is a time consuming process. Measurement using absolute instrument is a time consuming process. Sir, why it is a time consuming process, sir? For example, I want to measure the current by using one of the absolute instrument. Take the example is tangent galvanometer. Tangent galvanometer is the one of the example of absolute instrument, sir. If you want to measure the current by using this tangent galvanometer, first we can conduct one experiment where you can get some flux density, deflection, number of turns, you can get cross-sectional area, you can get, there is one formula is there, you can substitute in that formula, then we can get the current. That much of process is involved. But in our daily life, I told already, in our daily life, we don't wait for more time, sir. Connect the meter in the circuit, switch on the supply, pointer is deflected, get the reading. Like that we want. We don't wait for more time. Understood, sir? That's why these instruments are not used in our daily life because of time consuming process, sir. Measurement using absolute instrument is a time consuming process. Okay, that's the reason why these instruments are not used in daily life. But even though these are more accurate, we are not preferring in our daily life. Then these instruments are used in standard laboratories and to calibrate the secondary instrument. What I told, sir. Okay, this only we can use. Understood, students? What exactly absolute instrument? One point to remember here. One point to remember here. Which of the more accurate instruments means absolute instruments are more accurate instruments. Why these are not used in our daily life is because of time consuming process. Why these are more accurate is because of less power consumption. These points you concentrate. How these can measure means in terms of physical constants. Understood, sir? Now, what are the examples of absolute instruments, sir? These are the examples of absolute instruments. Yes, students, because these are not used in daily life. That's why most of the students, we are not seeing these ones. We are not seeing this type of meters because these are not used in our daily life, because these are only in scientific purposes only we are using. That's why, and only in some standard laboratories only they are using. That's the reason why we are seeing even in our colleges also we can't see. Maybe tangent galvanometer may be available, but remaining meters we are not seeing in our colleges, sir. Understood, sir? Because these are used only in the standard laboratories. Yeah. This, what are the examples of absolute instruments, sir? This is this these are the examples. This is a Rayleigh's current meter, sir. It is a Rayleigh's current meter. Yes, sir. This one, sir. Sorry. This is the Rayleigh's current meter, sir. Rayleigh's current meter. This is a tangent galvanometer, sir. This is absolute electrovoltmeter. Absolute electrovoltmeter. This absolute electrovoltmeter, sir. Absolute electrovoltmeter. And this is the Lagrange method of, it is a Lagrange method of, this is a Lagrange absolute method, sir. It is a Lagrange method is also one of the absolute methods, sir. That means, what is the examples of absolute instrument, students? The examples of absolute instrument is tangent galvanometer, tangent galvanometer, tangent galvanometer. The another one is which one, sir? Rayleigh's current meter, Rayleigh's current meter. Yes, students, please concentrate, sir. Next, absolute electrometer, absolute electrometer, electrometer. The fourth one is, yes, sir, Lagrange method, Lagrange method. Okay, these are the, yes, students, this Lagrange method. These are the examples of absolute methods, Lagrange method. Yes, sir. By using tangent galvanometer, what you can measure, sir? Current. By using Rayleigh's current meter, what you can measure, sir? Current. By using absolute electrometer, what we can measure, sir? Voltage. By using Lagrange method, what we can measure, sir? Resistance. These are the absolute methods of measurement, sir. Whatever the parameters we are measuring by using these methods, these are the more accurate methods, sir. Whatever the parameters we are measuring by using these methods, these are the more accurate methods. By using tangent galvanometer, what we can measure? Current. By using Rayleigh's current meter, current we can measure. By using absolute electrometer, voltage we can measure. Lagrange method used to measure the resistance. Understood? These are, sir, questions we may expect who are preparing for PSUs, mainly for GENCO, TRANSCO, DISCOMs, SSC-JE, even for SSC-JE also, ISRO also, sir. Question may expect simple questions like this, sir. Which of the following is absolute instrument? In these four, any is given, that you select absolute. These four is mainly the absolute instruments. Except these four, remaining most of the all the instruments are, remaining instruments are secondary instruments. Then in competitive point of view, remember like these, students. Just for remembering purpose, I am telling. Remember only absolute instrument in competitive exam, mainly for what I am telling for objective type. Remember only absolute instrument. Once you know the absolute instrument, remaining all instruments are the secondary instrument. Like that you remember. Okay, which of the following is more accurate instrument? In this way, any instrument is there, that is the more accurate instrument. Which of the following is absolute instrument? A tangent galvanometer is used to measure. An absolute electrometer is used to measure. Like that we can expect the questions. Yes, students, you please concentrate how the questions we can expect based on the concept. Clear, sir? I think most of the students, they are not seen, we are not seen in our laboratory, even in our colleges also we are not seen, sir, because these are not used in our daily life. Only in scientific applications only we are using. That's why the study of electrical and electronic measurement is not study of absolute instruments, sir. Our study is secondary instruments only. Our study, because those instruments only we are using in our daily life. That's why you want to mainly concentrate on the second. Yes, students, understand what the points you want to remember in the case of absolute instruments. Next, come to the second. Yes, these instruments you seen in our daily life. Many times you seen, sir. Every day once we are going for college, compulsory we go for laboratory. Once we are going for laboratory, in many laboratories, everywhere these instruments you seen, sir. Now these are our instruments. These are using in our daily life. These are the secondary instruments. Yes, sir. Then how to define the secondary instrument, students? How to define the secondary instrument? Yes, sir. Which measures the unknown quantity in terms of parameter under measurement, sir. In terms of parameter under measurement. Yes, students, please concentrate. Which measures the unknown quantity in terms of parameter under measurement. Sir, for example, I am measuring the voltage, sir. Directly I will get the voltage, sir. I am measuring current. Directly I will get the current. I am measuring the resistance. Directly I will get the resistance. I am measuring the power. Directly I will get the power. That is nothing but a secondary instrument, which measure the unknown quantity in terms of parameter under measurement. But that is not the case in absolute instrument. I am measuring voltage means directly I don't get voltage. I will get some physical parameters. Substitute in one formula. Then I will get the reading. Then I will calculate what is the value I want to measure. Understood, sir? Okay, that is the difference is there. That's why which measures unknown quantity in terms of parameter under measurement. Yes, students? Yes, sir. Please concentrate. Next. That means these instruments are so constructed that the deflection of such instruments gives the magnitude of electrical quantity we measure directly. Whatever the magnitude of electrical quantity we are measuring, that quantity will be measured directly. Take the example of voltmeter, sir. This voltmeter directly gives the voltage. Take the example of ammeter, sir. This ammeter directly gives the current. Directly gives the which one, sir? Current. Take the example of ohm meter, sir. This is ohm meter, students. This is ohm meter, sir. Take the example of ohm meter, sir. This gives the resistance directly. Understood, sir? Okay. This is ohm meter that gives the direct resistance, that gives the voltage. That means whenever supply is switch on, pointer will deflect and directly gives the reading. Not only this instrument, even you take any digital instruments also, those are also instruments or secondary instruments, sir, which gives the parameter under measurement directly. Take the example of DMM, digital multimeter. Connect in the circuit, switch on the supply, then the digital data directly gives the voltage. If you put in voltage mode, if you put in current mode, then directly gives the current. Understood? This not only analog instruments, sir, even digital instruments also secondary instruments. Sir, except absolute instrument, remaining whatever the instruments are there, those instruments are the secondary instrument. It may be analog instruments or it may be digital instruments. Remaining all instruments are the secondary instruments. That gives the output, the parameter under measurement. Directly it gives the outputs. Yes, sir. Whose secondary instruments measurement is less accurate, sir, as compared to absolute instrument. For example, in a particular experiment, I am measuring some voltage, sir. When I measure the voltage by using absolute electrometer, when I measure the voltage by using secondary instrument, whose accuracy is less, sir? Secondary instruments is less accurate. No doubt at all. Why these instruments are less accurate, sir? Because of more number of mechanical moving parts. Once there is a more number of mechanical moving parts internally, the power consumption is more. When the power consumption is more, these instruments are less accurate, sir. These instruments are less accurate. Understood, students? Sir, Ravi Kiran, yes sir. Doubt is which one, sir? The reading will be same or not? You are comparing secondary instruments and absolute instruments means then absolute instruments are less accurate as compared to secondary instruments. Sorry, secondary instruments are less accurate. Please correct that one. Secondary instruments are less accurate as compared to absolute instruments. Yes, sir. Why these are the less accurate, sir? Because of more number of these instruments are required to be calibrated by comparison with either an absolute instrument or with, that means I told already, all the secondary instruments are calibrated by using the absolute. For the calibration of secondary instrument. We can use the reference is absolute instruments. These are less accurate. These are less accurate instrument. These instruments are less. Then what, sir? These instruments are less time consuming, sir. Yes, this is the one advantage here. Because of this less time consuming only, even though it is a less accurate, these are more preferable practical. These instruments are generally used in practice. In our daily life, these instruments are more preferable. These instruments are more preferable. Yes, students. Sir, why these instruments are more preferable, sir? Because of less time consuming. Connect the meter in the circuit, switch on the supply, deflection of a pointer, directly use the reading. Understood? That's why these instruments are more preferable practically. Even though it is a lesson. I told, in our daily life, accuracy is not the main consideration. Time is the main consideration. In scientific only, time is not the consideration. But accuracy is important in scientific point. Understood, sir? Okay, that point to remember. Yes, sir. Okay, this about what exactly? Absolute instruments and second instruments. But based on the function of instruments, yes, sir, very important, sir. Based on the function of instrument, the secondary instruments are further classified as indicating instrument, integrating type instruments, recording type instruments. Remaining whatever the instruments I will discuss, all those instruments are the sub-classification of secondary instruments. Remaining all instrument, whatever I am going to discussing here, that is the sub-classification of the secondary instruments. That is the indicating instruments, integrating instrument, recording instruments. Yes, students, please concentrate. Sir, what do you mean by indicating instruments? What do you mean by indicating instrument? Sir, which measure the instantaneous value of parameter under measurement. Sir, for example, take the voltmeters and ammeters. Sir. Voltmeters and ammeter. Connect that voltmeters and ammeters in the circuit, sir. If you connect that voltmeters and ammeters in the circuit, switch on the supply, sir. Then the pointer will deflected. The pointer will deflected. Then whenever deflecting torque, what is the deflecting torque, what is the controlling torque, later I will explain, sir. Whenever deflecting torque equal controlling torque, then the pointer will comes to the steady state, sir. Then that measures the what is in that instant, whatever the voltage or whatever the current is there, then that value only it measures. And whenever you can switch off the supply, again it goes to zero deflection. Again it goes to zero. That's why it measures instantaneous value of parameter under measurements. At that time, whatever the value is there, that value only it measures. It can't store any data, sir. Again, if you switch off the supply, again it goes to zero. Again it goes to zero. That's why it measures instantaneous value of parameter under measurement. But point to remember, sir, whatever this instantaneous value is there, this instantaneous value may be average value or RMS value. That depends on the type of meters. Based on the scale calibration. For example, it is a PMMC meter, sir. If it is a PMMC meter, then that instantaneous value, generally PMMC means you take the average values. It measures the average value. If it is MI meter, sir, moving iron meter, whatever the instantaneous value is there, that value is RMS value. Why? Because MI instrument measures the RMS values. It is a AC instrument, used for AC. MI instruments are used for both AC and DC, sir. But generally, the scale is calibrated in terms of RMS. The scale is calibrated in terms of RMS. Understood? That's why that instantaneous value may be average value or RMS value based on the type of instrument we are using. Based on the type of instrument we are using. Understood, students? You please concentrate, sir. What exactly? Which measures instantaneous value of parameter under measurement? That instantaneous value may be average value or RMS value based on the type of instrument we are using. Yes, sir. Yes. Indicating instruments are those which indicate the magnitude of an electrical quantity at the time when it is being measured. At that time, whatever the quantity is there, that quantity only measures. Again, if you switch off the supply, then it goes to zero. Next, the indicators are given by pointer moving over a calibrated scale. That means in an indicating type instrument, this indicator, that is a pointer. this pointer is moving on the calibrated scale. Whenever these two torques are equal, deflecting torque equal to controlling torque. Yes, sir. Whenever this deflecting torque equal to controlling torque, then the pointer will comes to steady state. Sir, what is the deflecting torque? What is the controlling torque? Later on that I will explain. Up to now, you remember this point. Yes, sir. Then what are the examples of indicating type instruments? What are the examples of indicating type instruments, sir? This ordinary ammeters, voltmeters, wattmeter, frequency meters, power factor meters. All these are the examples of indicating type instrument. Whatever the voltmeters, ammeters we are using in our daily life, all these are the examples of indicating type instruments. Ammeters, voltmeters, wattmeter, frequency meter, power factor meter, ohm meter. All these are the examples of indicating type instruments. Yes, students, please concentrate. Sir, what is the recording type instruments? Yes, students, please concentrate, sir. What is the recording type instrument? Yes, recording type instruments are those which give a continuous record of the variation of the magnitude of electrical quantity to be observed over a definite period of time. That means which continuously record the signal, the unknown quantity which varies continuously. That continuously varied signal is recorded by the recording type instruments. That means how it can record means mainly in indicating type instrument there is a movement of the pointer on the scale. There is a movement of the pointer on the scale. But in the case of recording type instrument, there is a movement of the pen on a sheet of paper. Sir. There is a movement of pen on sheet of paper. Understood, sir? Based on the type of signal, based on the type of unknown signal, that paper, that pen, whatever the pen is moving on the paper, then that paper, on that pen, we can record that information. That means, here in such instrument, the moving system carries an inked pen which touches lightly a sheet of paper wrapped over a drum moving with uniform slow motions in a direction perpendicular to that of direction of the pointer. That means here pointer is nothing but a pen, sir. That pen is moving on the paper. Whatever the input is there, that input is recorded on the papers. Understood, sir? Take the example of ECG, sir. ECG is the one of the example for recording type instrument. Recording type instrument. Yes, thus a curve traced which shows the variation of the magnitude of the electrical quantity under the observation over a definite period of time. That means, if the sheet of paper is there, on that sheet of paper, whatever the pen movement is, the curve traced by the pen, that is the magnitude is given by the, whatever the input is there, that input magnitude is given by the variation of the pen on the papers. Understood, sir? This is about what exactly recording type instruments are. Then what are the examples of recording type instruments are? XY recorders. XY recorders is the examples of recording type instrument. Galvanometric recorders. Galvanometric recorders is the examples of recording type instruments. Recorders. Next, yes sir. Recording type voltmeters and ammeters used in the generating stations. Recording type. There is a recording type voltmeters and ammeters also, sir. Recording type. Yes, sir. Voltmeters. Recording type voltmeters and ammeters. And ammeters used in generating stations. Used in generating station. Used in generating stations. Yes, sir. XY recorders, galvanometric recorders, recording type voltmeters and ammeters used in the generating stations. All these are the examples of recording type instruments, students. Yes, sir. Here, this is the example for recording type instrument. There is a movement of this one, sir. This is the pen. This pen is moving on the paper, sir. This pen is moving on the paper. Then based on this, sir, there is a trace of one waveform, sir. That waveform is nothing but a indicated whatever the input we are giving, electrical quantity or we are giving, that is traced on the papers. Okay. Understood, student? You please concentrate. Here paper is automatically it is scrolling. Then on that the pen is moving. Then we are getting the some pattern that continuously recorded on the papers. Yes, students. Next, you please concentrate, sir. What do you mean by integrating type instruments? Yes, sir. one of the important example of integrating type instrument is energy meter, sir. Energy meter is the integrating type instrument. Sir, how to define integrating type instruments? Which measures sum or total of electrical parameter consumed by the circuit over some time intervals. Yes, students, please concentrate, sir. Which measures sum or total of electrical parameter consumed by the circuit over some time interval. That means electrical circuit means, for example, take energy meter, sir. In energy meter, in our domestic applications, whatever the loads are there, all the loads, how much energy is consumed, how many units of energy is consumed, that is measured by the energy meter. That's why, which gives sum or total of electrical parameter. Understood? Take the example of ampere hour meter, sir. Ampere hour meter. Then ampere hour meter is the unit of charge, sir. Ampere hour, that is ampere into hour. That means how much charge is transferred, how much charge is transferred by the steady state current in 1 hour of time. The total charge is measured by the ampere hour meter. There is ampere minute meter also, ampere second meter also, like that. Ampere hour meter. Ampere hour meter means how much charge is transferred by the steady state current in 1 hour of time. That is measured by which one, sir? Ampere hour meter. That gives the total value. Wherever the meter which gives the sum value or sum or total of, this is important, sir. Sum of total of electrical parameter consumed by the circuit over some time interval is nothing but which instruments are integrating type instruments. Students, integrating type instruments are those which measures the total amount of either quantity of electricity or electrical energy supplied over period of time. Okay, that is nothing but integrating type instrument. Ampere hour meter, energy meter, watt hour meter, all these are the examples of integrating type instruments. The summation given by such an instrument is the product of time and an electrical quantity under measurement. Understood, sir? The summation is nothing but a product of time and electrical quantity under measurement. Then what is the examples of integrating type instruments, sir? Very important, sir. Energy meter is the example of integrating type instrument. Energy meter. Next, watt hour meter, sir. Watt hour meter. Generally, energy meter is, this is watt hour meter. Next, ampere hour meter, sir. Ampere hour meter. Ampere hour meter. All these are the examples of which instruments are integrating type instruments. Understood? This is one, sir. This meter you seen in our domestic applications also. This is our energy meter, sir. How much number of units consumed by the load? How much number of units are consumed by the load for some time interval? That is measured by the energy meter. This is the ampere hour meter, sir. This ampere hour meter means there is AH, there is a minute, like that is also there, sir. That means, sir, in 1 hour, how much charge is transferred by steady state current is measured by ampere hour meter. If you take ampere minute means in 1 minute, how much charge is transferred by the steady state current is measured by ampere minute, sir. Understood, sir? Okay, these are what exactly ampere hour meter and ampere. Okay, this is one classification of instruments. Still, there is so many instruments are there, sir. There is so many instruments. Here I given what is the absolute instrument, what the secondary instrument. The secondary instruments based on the function, the instruments are classified into which ones, sir? Based on the function. That is, based on the function, it is classified into indicating type instrument, recording type and integrating type instruments. This one. Like that, based on the mode of operation, there is analog instruments and digital instruments are there. Based on the end of measurement, there is a deflecting type instrument and null type instruments are there. Understood, sir? Like that, based on the application point of view, so many instruments are there. There is electrical instruments, mechanical instruments and electronic instrument. Self-operated instrument and power-operated instruments also there. There is automatic instruments also there. Like that, so many instruments are there. Based on the principle of operation, there is a different types of instruments also there. Yes, In the next session, we will continue with the remaining type of instruments also, sir. Today class, I taken up to what exactly indicating type instrument, integrating type instruments and recording type instruments. Yes, students, you please concentrate, sir. Tomorrow session, we will continue with what is the deflecting type, what is the null type instrument, what are the mechanical, electrical and electronic instruments that I want to discuss. Then what is the self-operated instrument, what is the automatic instrument, then what is the panel mounted instrument, all these I want to discuss. Yes, students, sir, please concentrate. Students, this is who are taking the plus subscription. These are the course fee details, sir. For 12 months, apply my promo code BABU10, get the 10% discount and you pay 27,225 rupees, sir. This is for 18 months, sir. Apply my promo code BABU10, you pay only 34,650 rupees, sir. This is also for plus subscription for 24 months, sir. This is a 2-year program. Apply my promo code BABU10, you pay only 39,600 rupees. Yes, sir. This also for 1-year program, sir. Apply my promo code BABU10. Get the 10% discount. This is for iconic subscription, student. This iconic subscription, sir. This is the pay, course fee details. And this also for iconic subscriptions for 24 months. These are the course fee details, students. Yes, sir. These are India's #1 study channel, students. Creatics GATE, Electrical, Unacademy GATE, Mechanical Engineering, Unacademy GATE, Civil Engineering, Unacademy GATE English. This is our channel now, sir. Unacademy GATE English, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction. Students, please subscribe all these channels for more updates on different concepts on different subjects. Yes, students. Sir, thank you, sir. We'll continue remaining type of instrument in the next session, sir. And you please follow the power system subject every Saturday and Sunday 7:30 p.m. sir. The stability concept will be started. And tomorrow onwards at 9:30 p.m. at 9:30 p.m. every day, sir. Tomorrow onwards in our Unacademy learning app, sir. In our Unacademy learning app, the power flow studies concept will be started, sir. The power flow studies concept will be started. Yes, sir. All of you, thank you, sir. Tomorrow we'll meet.